Hey guys, welcome to today's lesson. Today we are looking at, we've been factorizing expressions, but now we're going to move on to difference of two squares. So it's a bit of a revision. I think you may have done this a little bit in year 8. Hopefully you remember how to do this. So first of all, what I'm going to look at is instead of factorizing, we're just going to revise expanding. Now, hopefully you recognize, first of all, what a difference of two squares looks like. If we look at these brackets, what do you notice? Hopefully you recognize that they're identical, but one's a plus and one's a minus. So how would you expand that? Well, you may know the rule, and that's great if you do. If you don't, we're going to get to there. So we're going to look at the expanding binomial products where we're going to times the two a's together to make the a squared. We're going to times the a and the 3 together to make the 3a. We're going to times the minus 3 and the a together to make minus 3a. And we're going to times the minus 3 and the positive 3 to make a minus 9. Now, of course, whenever we're expanding binomial products, we want to simplify if we can, and we can, because what you'll notice is that the terms in the middle will cancel. 3a minus 3a is 0, leave me with a squared minus 9. Now, of course, that's where the name difference of two squares comes from, because we have two squared terms. Okay, and difference is minus, so difference of two squared numbers. We have difference of a squared, a and 3, basically, when they're both squared. Okay, so hopefully you recognize that at least anyway. Now, the quicker term, as you know, if you square the first term, I get a squared, and if I square the second term, we get 9. We put a minus in between. That's a really quick way of doing things. Now, if I just take a side junket, we need to remember that they do need to be opposite signs. You might have a plus b and a plus b. That, unfortunately, is not a difference of two squares, because when we expand this out and get a squared, and we get the ab, we get another ab, and we get the b squared, what you'll recognize is that those two middle terms there are not cancelling because they're both the same sign. So ab plus ab makes plus 2ab. And that was that rule for the perfect square, okay, because it goes perfectly to a plus b all squared. So we have to ensure, in order to have a difference of two squares, that the brackets look identical except they are opposite in magnitude, plus and a minus. Because that way, when we do it the long way, we get the minus the AB plus the AB, and the ABs will cancel, and I'm left with a squared minus b squared. They are good notes to put into your book, by the way, if you haven't done so already, because that's where the rules come from, okay? And particularly this last part here, that is the rule that we use for the difference of two squares. Now, why are we doing this? Because realistically, when you're expanding, you could just do the long way the whole time, and you could absolutely. The problem is, if you're being asked to factorize, and let's look at the first one in question 2. How do you factorize x squared minus 16? Well, what we've taught you previously is to look for a common factor. In this case, the problem's going to be there is only one, and it's 1. That could come out as 1 x squared minus 16, and obviously there's not a whole lot of point in doing that because it's the same number, same expression. So it's not going to work. So what do we do? Well, there is only one thing we can do, and that is to know that this is a difference of two squared numbers. So if I know it's a difference of two squared numbers, and I square root the first term, I square root the second term, and I make them identical except for opposite magnitudes, x minus 4 and x plus 4, then I know how to factorize it, okay? So you do need to understand what difference of two squares means, because when you are factorizing, you have no other option. I always say, number one, always look for a common factor. And I'm not saying to go away from that, because that should be your first port of call. But if there's no more common factors, then we look for a difference of two squares. And of course, if that doesn't work, there's going to be another method that we look at for another style of question in next lesson. So let's have a look at these questions. If you want to pause it and, of course, go off and have a crack at these questions, you're most welcome to do so. Okay, question B. How do I know it's difference of two squares? We've got two terms. It's a minus in between. Difference of two squares. So I square root the first. I square root the last number. I then make sure they are the same term, but opposite in magnitude. Perfect. That's all you have to do. Job done. If you want to double check it and make sure it works out, go for it. Now in C, you'll recognize that if I square root 2x squared, I can't really do that, or not nicely anyway, because 2 is not a perfect squared number. But if I come back to that little rule up here, and I said, don't go away from this, number 1 and 2, always look for a common factor first, always. If I look at question C, there is a common factor. That common factor, of course, is 2. If I factorize that out, I get x squared minus 4. And now you might recognize something. That term inside there, it happens to be a difference of 2 squared numbers. So this is what I love, because now you can then square root both terms. Same except for magnitude, opposite magnitudes. You now have factorized that perfectly. 2 outside of x minus 2x plus 2. So please, you've got to start working really hard on learning what a difference of 2 squares is, because you have no other option to factorize than that. Now, of course, D, we step it up again. It looks quite challenging. It looks weird, and you might not know what to do. Now, funny enough, if you don't know what to do, what you could potentially do, might not work all the time, you might be able to expand the first set of brackets and then try and factorize. However, what I'm seeing here is I have the first thing that's been squared, I have the second thing, which has been squared, that's 5 squared, and we have a difference. So in fact, we actually have a difference of 2 squared numbers. Now, if I square root the first term, the square root and the square disappear. I'm left with x plus 5. Okay, it's my first term. I put a minus in between. I square root 25. I get 5. And then I copy the brackets exactly as they read, except we have a plus separating the 2 terms. Now, of course, you might want to leave it like that, but don't, because you can simplify. What's 5? Take away 5. Well, that's 0. So I'm left with x. Next brackets, I have x plus 10, and that has now been completely simplified. Now, worst case scenario, if you're not sure, you could expand the brackets. Sometimes it will work out nicely, but sometimes it doesn't, unfortunately. But if I do it this time, we have a perfect square. So we square the first, we times the 2 middle terms together, 5x, and double it, that's 10x. And we square the last, which is 25. We have the minus 25. Now, do you notice why this one does work quite nicely? The 2 25s will cancel. I'm left with x squared plus 10x. If I factorize the x out, look at that, we end up getting the same answer. So you might be lucky if you're not sure what to do, but certainly I'll be pushing yourself to do it the first way. Now, the last one I'm going to look at is x squared minus 7. Now, you might be going, okay, well, there's no common factor, Mr. Pay. You can't square root the 7, so there's nothing you can do. Well, at first glance, yeah, you're right. However, what is the square root of 7? Well, it's the square root of 7, isn't it? Could you not say the square root of 7 is that, and then copy the brackets out, and then put plus root 7? Not ideal. Understand that, absolutely. It's not an integer. It's an irrational number. But at least it's something that we can do. And if we were asked to factorize, well, there you go. I've factorized it out. And that still works because I have x squared plus root 7x, or x root 7 minus x root 7 minus 7, and it still works out to be true. Okay, look, so that is our difference of 2 squares. Remember, you have to learn this method when you're factorizing. You can get around it with expanding, but factorizing you certainly can't. Have a crack at the questions. If you have any problems at all, please message me on Canvas. Otherwise, have a great day.